here we go. I'm gonna have a highlighter going here. So anyways, inequalities and word problems. Obviously, when you have word problems, you'll have to read and interpret the question in order to produce. Watch this part. This is probably the new piece here. You're gonna have to produce the appropriate inequality. You're gonna have to come up with the inequality. Okay. This is on page 41, or whatever Xander said earlier in French. An inequality essentially provides a restriction. There, I'm going to use a different color for this one. Inequality essentially provides a restriction of possible answers. That's what an inequality does. It restricts, like you have, let's say you have the whole coordinate plane and the inequality says, no, either above or below this line, but not the whole thing, right? So you're restricting it a little bit. Things to keep in mind before we get started here. We have discrete versus continuous data, right? So discrete, things you can count. Things you can count, right? And they only exist in whole values. Only exist in whole quantities. Okay. Do you remember that from IPR, continuous versus discrete? I hope so. I think your teachers will have talked about it. So, right, coins, cans, people, etc. Those are just some examples there. So what's so important about this one is that you're gonna have to ultimately, once you've found the POIs, you're gonna have to round them. So let's say we're dealing with, people or cans, whatever I mentioned here. If your POI is let's say 6.918, I want you to write it down like that. But when we continue, I want you to go arrow to the side and say, hey, that's going to be rounded to 7/8. So you round to the nearest whole number. Sometimes it's a number of sandwiches, number of, you name it, toys, whatever the examples, cars, buses, whatever, we round, okay? So notice that we went from here to here, okay? When it says, when it's continuous, we don't need to round. So money, anything, surface area, things you can measure. Anything you can measure is continuous. So volume, length, weight, height, so forth is, so don't round. So I'll just give you some examples. Area, distance, temperature, money, weight, etc. I think you get the point. Don't round. Okay? You don't have to round the POI. Maybe I'll just say it one more time. Don't round POI. You don't need to do that there. So that's I think I just want to make sure you understand that, because it will be an issue down the road. Okay, and then almost all cases, the next point I want to make is almost all cases involve data that cannot be negative. Therefore, your graph will be restricted to quadrant 1. Your graph will be restricted to quadrant 1. And here is the stating the implicit constraint. this is the implicit constraint is we're saying that both x and y have to be greater than or equal to 0. Okay. Both x and y are greater than or equal to 0. So I have the same, I would like you to have this scenario here. No context with a context. So this is not a word problem. This is when we have a word problem. Sorry. Word problem. And I'm going to have a ruler here. So when we don't have a word problem, it's all 4 quadrants, right? It's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All 4 quadrants. Like your calculator actually would not know the difference, is what your calculator would show you. But we need to, when it's a context, this is not acceptable. Anything out here is not acceptable. Quadrant 1 only. Okay. So I want you to copy this graph onto here, and we can be quite specific here. Let me zoom in a bit. So I'm gonna just help you out. It goes through between 20 and 30, halfway between 20 and 30. So we're gonna do the same here. Put a point there, and then we're gonna follow this line, and it goes through 20, 0. You see that here? You go 20, 0 right there. And I don't want you to extend past the axes. I want you to just go straight from one intercept to the other intercept, like that. Then we're going to follow the dashed line. It goes through, it's just one box over 10. And it goes through 40, 0 right here. 40 zeros right there. And I'm going to make that my dashed line. Do not go past the axes. Okay, very important. And you can tell that the solid line, this one here, we shaded below on this one. Okay, so I'm just going to quickly do that, but do not shade past. You have to stay within your quadrant. So you have to be a bit careful here. This is where coloring between the lines, they were preparing you your whole elementary years were just to prepare you for this moment right here. Color between the lines. Okay. And then the dashed line we shaded above, right? If you follow the dashed line, it's above. It's a little bit easier, so all of that would be gone. And we're assuming reverse shading again, right? This is a system. All of that is gone. Everything above that line is gone. So how is it different? What will be different between one and the other? Let's add some variables. Still shading. Okay. Let's add some variables to our axes. Let's say this would be cars and buses. So let's say we're trying to fit cars and buses onto a parking lot, and that's what the question is. There will actually be a question like that down the road. But we have cars and buses. Over here on the left, it's just x and y. X and y. We have no idea what the variables are. We just call it x and y. Here it's cars and buses. We're down to quadrant 1 only. I'm going to use my red pen for this one. Over here, the solution region was everything. It just extends indefinitely. So all of this is my solution region. And I only have one POI on this one. If this is my solution region, there's only one POI. So let's make that go over here. I'm guessing, I'm just guessing here. Yeah, that's 1219 or something like that. Sorry, 12.9. We're just guessing. Okay, we're just estimating. It's not the greatest because we're going to use our calculator down the road. Okay, only one POI. So this only one POI. When you bring it to when you add a context to it, now our X and Y axis are also part of the game. Okay, so so this POI is still the same. Let's bring that in here. 12.9. But these two are also POIs now. 20.0 that is, and this one is 40.0. We have 3 POIs here. And my solution region is restricted. It cannot go past below the x-axis. My solution is like this. So our graphs, when we have a word problem, are going to stop with the x-axis or the y-axis. They're not going to go past it. Okay, we're going to stick within this solution region because you can't have negative buses, or right, in this case you can't have that. So there we go. Anything else? Maybe I should say this. X-intercepts are POIs in a word problem. Good? All right. Now, before I do page 42, I always go through my notes ahead of time, right? Just to see if I missed anything. I have sticky notes on my original. I'm gonna fast forward to page 48 before I do this part, because I think it's better to have some keywords down before we start. Okay. So go to 48, which is a blank page. And I'm going to give you some keywords, and you will know right away when you read those which way your inequality goes. Keywords when writing inequalities. If you see in the question, and I unfortunately I cannot guarantee you that I'll give you all of them, but most of them. If you read up to, or if you read at most, or a maximum of, or a capacity of, holds up to, last one, no more than, any of those, or something that's similar to this, all of them, you have to make sure that you use this inequality. If you do that, you're already in good shape, okay, if you identify that. Next, if you read these ones, this one is a shorter list. if you have to have at least, 500 roses in a bouquet, or something like that, and then, or a minimum of, or no less than, and maybe there will be more that are going to come up. We might add to this list. But if you have those words show up, you have to expect an inequality symbol that looks like that. And maybe we'll break this, right? So that we're not mixing them up. So this is your go-to. If you're writing inequalities, maybe go to this, or if you want to add this to your study sheet, this is going to be a good one to have because you're going to be writing inequalities quite a bit. Still doing all right. You got this down? I'm going to go back to 42 now. And I'm going to tell myself on 42, at the top, see keywords on page 48. See keywords on page 48. Writing inequalities given a word problem. I do have the keywords here as well, but I kind of summarized them nicely there for you. It's nicer. It's just a nicer setup. Okay. So I think I used two different highlighters for this part, just to kind of for it to pop. Yeah, I'm gonna have pink and orange. You can use whatever colors you have. So I'm gonna let X be the number of people, and that's going to be in pink for me, and Y be the number of pets. I think you would all agree that looking at the variables, we have discrete data, right? I make a note of that because later on, when you have to find the POIs, you would have to round. And because you can only have whole quantities here, so it's discrete. Okay, so let's practice writing the inequalities. A building can accommodate no more than 400 people. Okay, I want you to think of, right, there are people here. So that's very specific just to this variable X. So we're going to go X, and we're going to have the 400 in there. And the kicker is, which way does the inequality symbol go? I'm going to highlight people here. This is very specific to just people. Right? So what we're saying here, we're going to set up a restriction where we can have no more than 400 people. So if X represents the people and 400 is the maximum you can have, then this number of people has to be less than or equal to 400 to make sure we don't surpass the 400. Okay? So 1, 2, 3, 4, 5, 6, 7, 399, even 400 is still acceptable. 401 would make this false, right? So keep that in mind. And so if you think of no more than, that gave me the inequality. That's a keyword for a restriction. And I'm just going to see if I have that one on 48. Let me check. Oh yeah, no more than is right there, and we have it facing this way. And you might wonder, Mr. Dixon, when is it like greater, like less than without the equal sign, or greater than? Don't worry about that. Word problems, I think there's one instance that I'm a little sneaky where I have it in, but it's not going to be on a test. It's just part of the homework. Okay. So let's keep going. A dog park can hold up to 45 dogs. So if you think about it, this is very specific just to dogs. This is talking just to the amount of dogs. And can hold up to, right, this part right here is going to give us our inequality. So dogs are represented with the variable y. The 45 has to come in there. So we need to make sure that the number of dogs does not surpass 45 if you look at the context here. So we have to say less than or equal to 45. And I'm just going to give this an orange highlighter there as well. Okay. A dog park can have up to 100 dogs and owners combined. Another scenario. This is where I need to draw. This is dogs and owners combined. This is x and y that are being referred to, both variables. Okay, so this is where it takes a twist. Instead of just x, just y, we're going to say that the number of owners or people and the number of dogs, like combined, something 100. Which way is the inequality going to go? Well, you have two choices. You go and look up the keywords, or you just say, well, this combination of owners and pets has to be less than or equal to 100. Like we can accommodate up to 100, but not more. Okay, so this is the inequality that results from that statement. Is your head hurting already? I bet it is. Can I ask you to take some time and let me just peek here. All I want you to do is your homework is to finish this page, write the inequalities you see, okay, plus take home AC. Both are important. 3 inequalities, you're going to have to do that again on your own, okay? Thank you guys. Have a great weekend. Stay warm.